Hello guys, welcome to my channel, and in this video I'll explain you article number 2.6.1 relation between field and potential. You know both this term we have studied about both this term electric field and potential. So I'll just read the lines and explain the meaning to you. Okay, so let's get started. So the first line is consider two closely spaced equipotential surfaces A and B with potential values V and V plus delta V, where del V is the change in the V in the direction of the electric field. So you see, uh, we are given two equipotential surfaces. What is equipotential surface? We studied in the previous paragraph. Okay, so any surface which has equal potential all throughout it is called equipotential surface. So A is a equipotential surface and B is another equipotential surface. Now, and the potential values of A is V and the potential value of uh, B is V plus delta V, that is, and the electric field is from A to B, so the change in the direction of electric field is delta V. Okay, now let P be a point on the surface B. So we consider a point, any general point on P, and del L is the perpendicular distance of the surface A from P. And now we'll draw perpendicular from this point to this surface. So del L is the perpendicular distance between the point P and the other surface A. And after this, imagine that a unit positive charge is moved along the perpendicular from the surface B to surface A against the electric field. Now suppose we move a unit positive charge from P to A, okay, along this del L, okay, this perpendicular distance. So you know we are doing the work against the electric field in this direction and moving it against this direction. So we have to do a work, certain amount of work in moving this charge, unit positive charge. So the work done in the process is this much, okay, because you know work done is what? Work done is force into displacement, okay, and what we are doing. So if only we consider the magnitude, so force is what? Force is charge times electric field intensity. This is the F is equal to QE. And what is the magnitude of charge here? So the magnitude of charge here is 1, so this will become E, okay, just here, okay, I'll just take the magnitude of E, and displacement is what? Del L is the displacement. Okay, so this is the work done in moving the charge against this what, like in the opposite direction of the field along the point P to A. Okay, this is the work done, you see. Now this work equals the potential difference VA minus VB. Okay, and because we know this has potential V plus del V and this is potential V, okay, so this is the and you know what is the work done in moving the charge between, what is the potential difference? We know potential difference is work done per unit charge. Okay, so this work done is what? This work done is what? The potential difference. Okay, so we can equate the potential difference between V and two surfaces as this much. Okay, so some modulus E times del L is the potential difference of the 2 points, so V minus V plus del V, and that is, it will give me minus del V. Okay, so and on cross multiplying I'll get this modulus of E is minus del V upon del L. Okay, so what does that mean? So it means that the electric field, so you see this is what? Del V by del L. This is the gradient of potential. And what do I mean by gradient? It is the change in potential with the change in distance. Okay, as you see, there is a, when I move from this surface to this surface, there is a change in distance. Okay, then there is a change in potential. So what is the change in potential with respect to change in displacement? Is the potential gradient. So okay, and this minus sign, what does that mean? So you see the potential, the electric field is in this direction, and this minus sign will mean that the potential will definitely decrease in this direction. Okay, the negative gradient shows that the potential uh, decreases in the direction of electric field. Okay, so this will have, this surface B will have less potential, and this have more potential. Electric field is in the from higher potential to lower potential. Another way of understanding is this, electric field is from definitely from positive to negative side. Okay, higher potential, lower potential, definitely this will have negative potential. This is also suggested by this. So very important, this is a very important relation. Electric field is negative gradient of potential. So now del V is negative, del V is equal to minus del V, modulus of del V, we can write this. Okay, so because del V is negative, so we have put del V as minus del V. On putting minus del V, this will become or if I take only the magnitude of V, this is plus del V by del L. Okay, so we can derive two results from this. We thus arrive at two important conclusions concerning the relation between electric field and potential. First one is electric field is in the direction in which the potential decreases steepest. Okay, so as I told you, electric field definitely will decrease. Electric field is in the direction of, okay. So now second point is magnitude is given by the change in the magnitude of potential per unit displacement normal to the equipotential surface at the point. So if we have to find the magnitude of electric field at a point, so what we'll do, there is a equipotential at this point, at that particular point. So the displacement, the change in potential per unit displacement normal to the surface will give me the electric field at that point. So I can just differentiate the potential value with dl, okay, and I'll get the electric field at that point. So we have derived two result here. This relation is very important. Okay, that is electric field negative gradient of potential, and how can we find the electric field. Okay, so I hope you understand this paragraph. If you understand, please give it a thumbs up and subscribe to my channel. Okay, and if you find any mistake in the explanation, do let me know and others know, so that I